Okay, so as we pick back up in lesson 6.5, have you read the word problem? No?
No, nothing.
Okay, well, let's start by reading the word problem. Okay? First step, read the word problem and see that it's not as horrible as you think it is. Okay. For meteor crater in Arizona, the formula D equals 2 times the cube root of V over 0.3. Yes, looks ugly, but here's my thought. They gave me a formula. I love when they give me a formula because then I have something to use. Okay, it relates the diameter of the rim in meters to the volume in cubic meters. What is the volume of meteor crater given that the diameter is 1.2 kilometers? Remember that there are 1,000 meters in 1 kilometer. Okay, lots of information, yes? Again, I want to start off by pointing out, what did they give me? A formula. So know that we're going to use that formula. I'm going to go ahead and write it down here where I'm going to do my work. It's 2 times, and that is the cube root of V over 0.3. Now, notice it relates the diameter. So the D in that formula stands for diameter. Do you notice it says diameter what? In meters. So it relates the diameter. So D is going to stand for diameter to the volume. And volume is in cubic meters. Realizing cubic meters is just meters to the third, right? Typical volume measurement that you guys have been messing with since elementary? Or am I going back too far? I feel like volume goes back to elementary, doesn't it?
Yes.
Okay, so now the question. What is the volume? So what are we trying to find? We want to find V, right? Of course, V is under the square root. We're going to have to do some work. But our goal is going to be to find V. Given that the diameter is 1.2 kilometers. Now, they then gave us extra information in parentheses. Remember that there are 1,000 meters in a kilometer. Have you caught on to why they're giving that to us? Yeah, what did it say up here? It said diameter of the rim in meters. What diameter was I just given? Kilometers. So what's something we have to do here? Yeah, this formula works with meters. That's just the way that formula works. So we need to think about 1.2 kilometers, what that is in meters. If there's 1,000 meters in 1 kilometer, how do I turn 1.2 kilometers to meters? Multiply it by 1,000. Because they are
1,000.
Metrics just is hard. I much prefer to multiply it by 500. 5,000.
Okay. There are 1,000 meters in 1 kilometer. So we're going to take 1.2 and multiply it by 1,000, and we're going to get 1,200 meters. Okay? I don't know. I know when I taught middle school years ago, I had a little strip that I would hand out, and you could like count decimal places, left or right. I don't know if you guys ever did that or not, but that would be the same thing. There are 3 decimal places between kilometers and meters as base on that little strip. And you're counting decimal places. So, okay guys, are we ready to try this formula? 1,200 meters is going to go in for what? What's this go into for our formula? This is D, right? This is our diameter. So, let's fill in our formula here. D equals, so 1,200 equals 2 times the cube root of V over 0.3. Okay. This goes back to Friday. Solving for a radical. In this case, we're trying to solve for V that's under that cube root. What should be our step to start with? Hold that step for later. You said cube it. I don't want to cube it yet.
Divide by 2.
Why would I maybe divide by 2?
Because you want the radical by itself.
Uh-huh. Yeah. Before I can cube it, I need to get the radical by itself, which is why I said hold that thought. In order to get that radical by itself, what's happening right now? Right now it is 2 times the radical, yes? If it's 2 times the radical, what do I have to do? Divide by 2. If I divide one side by 2, must divide the other side by 2. 1,200 divided by 2? 600. On the other side, the 2's cancel and what remains? Cube root of V over 0.3. Okay. Now what? Is my radical by itself?
No, yes.
I have that cube root with stuff under it. Is there anything outside of it hanging on? No. So if the radical is by itself, what do I do?
You can do outright.
Now I'm ready to cube it. Since this is a cube root, in order to get rid of the cube root, I need to raise it to the power of 3. If it was a square root, we'd raise it to the power of 2. If it was a fifth root, I'd raise it to the power of 5. I totally should not be writing and talking at the same time. Okay. Sorry. I don't know what, I hope I said the right thing, but I totally wrote the wrong thing for a moment. Okay, it was a cube root. I'm raising it to the power of 3. Now, I don't know about you guys, 600 to the third, I'm sure my calculator can tell me. I can also just leave it at 600 to the third for a moment. Okay, it's something big, right? I'm going to just write it as 600 to the third. I'll plug it into my calculator in the end. On the right, what happens when I cube the cube root?
The cube root, the entire cube root cancels.
The cube and the cube root cancel each other out. And what am I left with?
V over 0.3.
V divided by 0.3. Are you starting to see the light at the end here? We're working through the hard steps. We're getting to the easier steps. What do we have to do to finish getting V by itself?
You have to multiply by 0.3 to both sides.
Okay, if this is V divided by 0.3, the opposite of dividing by 0.3 is to times, multiply by 0.3. What I do to the left? We do to the right. So, at this point, my 0.3's cancel. I'm going to have V equals whatever 0.3 times 600 cubed is. And that's where I grab the calculator, right? I'm not asking you to use your brains. I'm asking you to use your calculator. Well, I am asking you to use your brains. To be smart and use your calculator, right? So 600 to the third times the 0.3 was what? 64,800,000. So 648 and then 5 zeros. What kind of label would that have? It is volume I'm trying to find, and volume up there was cubic meters, or I traditionally say meters cubed. You might might not have liked that, but I would like to say that that could have been a lot worse.
Once you broke it down, it made sense.
Okay, and that's what I would like to think, is that breaking it down, it makes, those are steps you've seen, right? Those are steps you can do. May look overwhelming to begin with, but
Just the numbers.
that doesn't mean it's overwhelming.
Are you not like not even a little bit?
Not a little.
I'm first. I told you.
I was cold this morning in here, so.
It feels good.
Okay. Example 4. And whether I'm cold or not, heat's pushed up. Like I can't do anything about
Oh,
it.
I know.
So.
That's why I looked at it and I was like, oh my gosh, it's that cold, and then heat is all the way up.
Now, if you ever see it not pushed up and you're cold, then talk to me because maybe someone pushed it down. I didn't realize it, but yeah, that's the first thing I check in the mornings. Is the heat pushed up?
The heat all the way there.
It is.
The downfalls of having a window room.
Yeah. Okay. Example 4. Last Friday, we worked with solving equations that had radicals in them, yes?
Yeah.
We worked with, if there's just one radical, get the radical by itself, and then we'd raise it to a power on both sides, right? We often did squaring. If it was a square root, if it was a cube root, we'd cube it like we just did there. Okay. The difference in this section, there might be 2 square roots instead of 1. And notice a big difference. There's an x, another x that is outside of the radical. When you have that other x outside the radical, you want to watch out for, remember on the front we talked about it, Gollum's talking about it today, extraneous solutions. Okay, so I'm going to write a little note here in this section that we want to check for extraneous solutions. Okay, this is the key section that we're going to run into extraneous solutions. Partially because that x outside of the radical, we tend to get extra solutions there. Okay, ready to try A?
Sure.
Square root of x plus 7 minus 5 equals x.
And 5 to go.
There's one radical. What is our job with that one radical?
Get it by. Get it by.
Get it by itself. And so, what's hanging outside the radical I need to move? The 5. It's being subtracted, so we're going to add it. Okay, that's pretty basic there. We now have square root of x plus 7 on the left. Minus 5 plus 5 cancel. On the right, what is x plus 5?
X plus 5.
Good. X plus 5 is x plus 5. They're not like terms, right? So we can't add them. Okay. What's my next step? I've got the radical by itself.
Cube it. Not cube it.
Square.
Square.
Okay. Raise it to some power. Is that a better way to put it, generally speaking? Because this is a square root, we're going to raise it to a power of 2. If I square the left, we're going to square the right. On the left, what is the square root of x plus 7 squared?
X plus 7.
The square root and the square cancel each other out. And so we have x plus 7. On the right, what is x plus 5 quantity squared?
X squared plus
X squared plus 2.
You are 2/3 right.
Could you leave it?
You cannot leave it.
Plus 10.
Plus 10 what?
What?
I didn't know if you knew something back there, if you were just throwing in a random plus 10.
He was throwing a random plus 10.
Okay.
Is the random plus 10 right?
So, x plus 5 squared means x plus 5 times x plus 5, correct?
Yes.
how do you multiply x plus 5 times x plus 5?
Distribute. Right.
Distribute.
Or no,
X squared plus 10.
Or if you prefer the FOIL word,
X squared plus 10x plus 25.
uh-huh. Okay, so there's a trick here. The common mistake is to say x squared plus 25, isn't it?
yes.
You guys all fell for it. Typical, that's what I expected, okay? The goal is to not fall for it continually, though, okay? So when you see this x plus 5 squared, realize you need to FOIL or distribute, whichever your brain thinks better. It's all the same, but FOIL or distribute. So that's why I went ahead and wrote out x plus 5 times x plus 5, because I had a feeling if I wrote that out, it would start to trigger that, oh, that's what we have to do. Okay. X plus 7 on the left is still that x plus 7. On the right, okay, you got it? X times x is x squared. X times 5 is 5x. But also, 5 times x is another 5x. Is it all right if I go ahead and say 5x plus 5x is 10x? And then 5 times 5 is 25. Thus, when I heard a 10 mumbled back there, I wondered, were we just throwing out a 10 or did we know something? It's just not a 10 though, it's a 10x. Okay, so where to go from here? I got rid of all my radicals, yes? I have x plus 7 equals x squared plus 10x plus 25. How do we solve an equation like this?
You slap everything together and say
Slap everything together and say it's done.
yeah. Just get some spackle and some duct tape. Get some flex
Spackle and duct tape to slap it all together.
Get some flex tape.
Okay, I'm gonna have to pass here.
Get some flex tape.
Let's take those even more.
We need to do some math with it. Okay, not some construction with it. We're gonna do some math with it. Okay. Here's what I'm gonna say. I have an x squared term, yes?
Yeah.
And I have an x term.
Yeah.
X terms. Because I have, so if the x squared wasn't there, I would say x is on the left, constants on the right, and solve from there.
Yes.
But I have x squared in addition to my x terms. So instead, we should probably make this equation equal to
X squared.
0.
Oh, nice.
Okay? So we need to make this equation. Remember, we had a chapter about solving quadratics, right? It was first semester. We solved quadratics. When we solve quadratics, we want our equation equal to 0 when there's x squared in x terms, usually equal to 0. So I like to keep a positive x squared. So I'm going to keep my x squared on the right because I like positive. How do I move x and 7 to join it?
Subtract x, subtract 7.
Okay, since it's a positive x, I'm going to subtract x. I'm also going to subtract x on the right, which means I'm subtracting x from 10x. And this 7, I'm going to subtract it on the right also, which means I'm subtracting it from 25. So I have 0 equals, because x minus x cancels, 7 minus 7 cancels. X squared stays x squared. What is 10x minus 1x? 10x minus 1x is 9x plus 25 minus 7. 18. Okay. Now I have 0 equals x squared plus 9x plus 18. If you really don't like that 0 on the left, then move it to the right. We have x squared plus 9x plus 18 equals 0. Okay, dig deep in those brains. how do we solve a quadratic like this? We had multiple different ways. There's a way I always encourage you to try first. It may or may not work.
Something vague.
I'm always going to encourage you to try to factor first. Because if it doesn't factor, we have to go quadratic formula. And you guys are really going to not like me if I say quadratic formula.
No thanks.
Good news is this factors. Do you remember how to factor?
I never really knew.
X squared. What does x squared break into?
You get
X and
them
X.
two
X and x.
smaller than
These two numbers have to do two things for me.
Yeah.
But they have
Product
to-
of one and the sum of the other.
yeah.
Product and sum. So I need two numbers that are going to multiply to be 18. So that means they have a product of 18. And they add to be 9. So a product of 18, a sum of 9.
3 and 6.
6 and 3.
3 and 6, 6 and 3, doesn't matter which way we say it, right? This is where at the time I made a list, didn't I?
Yeah.
I would, if I wasn't sure, I'd list my products of 18. 1 and 18, 2 and 9, 3 and 6, and I'd go until I found something. Is this sounding a teeny bit familiar?
Yeah.
Okay. If it multiplies to be positive and adds to be positive, both signs are positives. Okay. We're getting to the easy part. We haven't actually solved. I need to work until I have x equals. Right now I have x plus 3 times x plus 6 equals 0.
So,
No, you said both of those equal to 0.
Coming back to us, set both parts equal to 0. So I'm going to say x plus 3 equals 0, or x plus 6 equals 0. How do I solve? If it's x plus 3 equals 0, we're going to have to subtract 3. If it's x plus 6 equals 0, I'm going to have to subtract 6. I get solutions of x equals negative 3, x equals negative 6.
Can it be x equals negative 3 comma negative 6, or do you have to have x's?
Now, before we move on, you need to check something.
No.
What did I mention up here?
Extraneous.
Extraneous solutions. Okay? Gollum says it. Tricksy mathematicians. Even better if you can, visualize him saying it in his Gollum voice and
Is that one here?
Lord of the Rings.
I've never seen either. So.
That's not me.
Oh, come on.
You can't do the voice.
Not really. Huh?
You can't do it? I don't want to try. I figured you could.
Okay, so we need to check our solutions. Okay? This is one we need to check our solutions. So, do you remember how to check solutions like this? We're going to take our answer, and we're going to go back to the original equation before I changed anything. So the original equation, and plug it in. Now, I tend to do this in my head. However, I have a little bit of space over here. The idea is if we're using the original, I'm going to say, okay, square root of negative 3 plus 7 minus 5 equals x, which is negative 3. Is that true? That's what I'm trying to figure out.
Yeah.
Negative 3 plus 7 is 4. The square root of 4 is 2. 2 minus 5 is negative 3. Does negative 3 equal negative 3?
Yeah.
It does. So negative 3 is good. It works. Now, I repeat the process with the -6. So square root of -6 plus 7 minus 5 equals -6. I'm trying to figure out, does it work? -6 plus 7 is 1. The square root of 1 is 1. 1 minus 5 is -4. Does -4 equal -6?
No.
No. So what did we just figure out? -6 is an extraneous solution. Thus, you need to check your answers. Okay? Okay, that was a lot, I know. Questions I can answer, gentlemen. Questions I can answer here? Did you at least kind of follow it?
Yeah.
Yeah, I
As long as I'm leading the way, it was good?
don't like it, but I got it.
Okay, I didn't say you had to like it. Okay, let's try B. Let's practice another one of these. It probably did. Maybe that's the thing. Maybe I run out of time to do all these examples. Holy cow. I want to get through B and at least C. So let's move. Okay, B. Square root of 5x minus 1 plus 3 equals x. What is the first piece you have to realize?
You have to get the one thing along. You have to get the radical.
Okay, I see. You guys got to help her out here. Get the radical by itself.
It came. It just took a minute.
So we want square root of 5x minus 1 to be by itself. So the first thing I'm going to do is I'm going to move the 3. How do I move a plus 3? We subtract it. So I'm going to have square root of 5x minus 1. My 3's are going to cancel. And on the right, what is x minus 3? It is
-3.
x minus 3. Got a square root here. How do I deal with the square root of 5x minus 1? In order to get rid of a square root, we're going to square it. If I square the left, we're going to square the right. What is the square root of 5x minus 1 squared? When you square square root, you just get whatever's under the radical. What is x minus 3 squared? Okay, so it's not just x squared plus 9, is it? Whatever it is, it's not x squared plus 9. There's more to it. So we do need to FOIL this, don't we?
Yeah.
Okay, so 5x minus 1, when we FOIL, x times x is x squared. X times minus 3, minus 3x.
Yeah.
And realize when you're FOILing by itself, it just becomes another one, doesn't it? Minus 3x and minus 3x is minus 6x. And minus 3 times minus 3 plus 9. If you leave out that middle term, it makes a difference, doesn't it? Totally changes the problem. Okay, I see x squared, I see x's. What's my solving technique? Make our equation equal to 0. I like having a positive x squared, so I'm going to keep my x squared on the right. To move positive 5x, I'm going to subtract 5x. To move minus 1, I'm going to add 1. So I'm going to subtract 5x, add 1 on both sides. 5x minus 1 plus 1, we've got 0. X squared minus 6x minus 5x. Minus 11x plus 9 plus 1 plus 10. So now I need two numbers that add to be 10. Excuse me. Rewind. Multiply to be 10. And add to be negative 11. So we need our product of 10 and our sum of negative 11. What multiplies to be 10? And generally just speaking, 1 and 10 or 2 and 5. Which one could possibly give me 11? 1 and 10, right? Because 1 plus 10 is 11. So that's what I have to think there. So x squared is x times x. Multiplying to be 10 is 1 times 10. Signs, how do we multiply to be a positive? It's either two positives or two negatives. To add to be a negative, we need two negatives. Okay. This is the easy part. Don't tell me your answers are negative 1 and negative 10. All that hard work goes down the drain. Okay. X minus 1 equals 0. X minus 10 equals 0. You end up with possible solutions of x equals 1, x equals 10. There was an x outside the radical at the beginning. We've got to check for extraneous solutions. Did you see how I checked for extraneous solutions last time?
Yeah.
Okay. Do you have to write out that check? No, you don't. Can you, though, if it helps you? Yeah. So I'm going to take 1, and I'm going to put it into my very original piece. 5 times 1 minus 1, square root of that, plus 3 equals, what am I putting in? 1. Okay, under my radical, 5 times 1 is 5, minus 1 is 4. The square root of 4 is 2. 2 plus 3 equals 1. That's a no-go. Okay? Repeat the process. This time it's 10. Square root of 5 times 10 minus 1 plus 3 equals 10. 5 times 10 is 50, minus 1 is 49. Square root of 49 is 7. We had a plus 3 here, and 7 plus 3 is 10. Will always be one works and one doesn't? No. It could be both works. It could be neither works. If you see in a homework problem, check for extraneous solutions, that is like your huge, like neon flashing sign saying, check, because something might not work. Okay. We need to look at C. Hoped, you know. What's different about C?
There's 2.
There's 2 radicals. And that does make a difference, folks. Okay? We had one on Friday with 2 radicals, didn't we?
Yeah.
But it was just 2 radicals. If you look at the last one we did on the front side of notes, it was just 2 radicals, nothing more. So it was, we got a radical on each side, it was piece of cake. This one's going to be a little bit more. Now, our rule is still to separate the radicals. We want one radical on either side. Never try and work a problem with both radicals on the same side. So, easiest radical to move to the other side is the square root of x. So I'm going to add square root of x to the other side. So on the left, I have square root of 2x plus 1. On the right, when I add square root of x to 1, I'm going to flip it, and I'm going to say square root of x plus 1. But yes, it is still just 1 plus the square root of x. Okay. I have my radicals on opposite sides. On the left, I have a radical by itself. What do you do when you get a radical by itself?
Put it to the power of 2.
Put it to the power of 2. We're going to square it. If I square the left, we square the right. On the left, square root of 2x plus 1 squared. What happens when you square that square root? Square root goes away. It just becomes 2x plus 1. On the right, are we squaring just a square root? No, we are not. So, this falls into the category more of we need to FOIL. We need to distribute. Okay? As I said, this is the tricky kind right here. You really have to work at it. So, my left is still going to be 2x plus 1. Okay, on the right when we FOIL, square root of x times square root of x is going to be x. Right. Square root of x times 1. Okay, and I'm going to write it out this time. So it is 1 square root of x, yes? Insides. What is 1 times square root of x? It is 1 square root of x. And last, 1 times 1 is 1. Okay, guys, here's the trick. We didn't get rid of our radicals. Okay, we're closer. If you clean this up on the right, stay with me. 2x plus 1 still on the left. What is 1 square root of x plus 1 square root of x? 2 square root of x. So on the right, I have x plus 2 square root of x plus 1. Okay, guys, the trick here is we got a radical by itself. We squared it. We got rid of that radical, yes? We still have one more radical. We need to get this radical by itself and square it, and then we'll be home free. So in order to get this radical by itself, I need to move over my x and my 1. So a positive x, I'm going to subtract x over. A positive 1, I'm going to subtract 1 over. On the left, 2x minus x is x. 1 minus 1 is 0. On the right, x's and 1's are gone, and I have 2 square root of x. I know technically I would say divide by 2 to get the radical by itself, but I don't want to create an unnecessary fraction. Because that is just multiplied, we can go ahead and square it here. So I'm going to square both sides. I'm going to have to bring it up here. When you take x and you square it, you're going to get x squared. When you take 2 square root of x and you square it, well, the 2 is outside, though. So when you square 2, you're going to get 4. When you square the square root of x, you're going to get x. So you get x squared equals 4x.
And then you take the square root.
You can't take the square root when this is a 4x. We need to quickly make it equal to 0, which means I'm going to subtract 4x. X squared minus 4x equals 0. Give me just a second, please. GCF is our factoring. I can't product and sum here, but I can factor out a GCF. Does that ring any bells? Factor out GCF. I would set each part equal to 0, x equals 0, x minus 4 equals 0. You end up with two answers, and when you check them, they actually both work here. Okay? Every problem's going to be a little bit different. The process. Getting a radical by itself, squaring it, and then having to possibly square a second time. That's the part you have to know. Okay? Attempt all the homework for tomorrow. Come back with questions if you have them, okay? I didn't know if you got the rest of that side, so there's those. In case you didn't get them. Okay, next one ahead, make copies that way. If you didn't get them, you have them. Okay, you're welcome.